The fact that I watch YouTube videos does not stop me from getting a job, or the fact that I have a job does not stop me from watching YouTube videos. As you can see, the occurrence of one of those events does not affect the other, and this is the basis of independent events. Welcome to another video, and in today's video we are going to be talking about the concept of independent events. We define independent events, we give examples about independent events, and stay to the end of this video where I give you the mathematics and the formula we use to work on independent events. So without further ado, let's jump into the video. So the first question you ask yourself is, what are independent events? So basically, two events are said to be independent if the occurrence of one of these events does not affect the other. That is, the chance that one of these events occurring does not affect the chance that the other event is actually going to occur. Let's take, for example, the event of watching a movie and eating. The fact that I'm watching a movie does not stop me from eating, and the fact that I've eaten does not stop me from watching a movie. In this case of ours, watching a movie and eating are actually two independent events, as the chance of either of them occurring does not affect the other. Another example, playing football and graduating from the university. So because I play football does not stop me from graduating from the university, or because I graduated from the university does not stop me from playing football. These two events are independent on each other, and the occurrence of playing football does not affect the occurrence of graduating. Watching YouTube videos and getting a job. So because I watch YouTube videos does not stop me from getting a job, and because I'm getting a job or I have a job does not stop me from watching YouTube videos. These two events are actually independent on each other. Let us assume we have event A and we have event B. The probability that event A is going to occur is given as P into bracket A, and the probability that event B is going to occur is given as P into bracket B. If event A and event B are actually independent events, that is, they are independent on each other, so definitely probability of A and probability of B is going to be equal to probability of A times probability of B. Or we can say probability of A intersection B is equals to probability of A times probability of B. Let's put this mathematical formula into practice. I am going to be assuming an example of a bag containing a total of 15 balls. Inside this bag we have 10 green balls and we have 5 blue balls. If two balls are picked at random with replacement, so we need to get the probability that we are going to be having a green ball and a blue ball. Please, emphasis on the word with replacement, because for independent events, our experiments in this type of situation must be done with replacement. It was stated that we are having two picks, so that means we have the first pick and we have the second pick. So in our first pick, what is the probability of having a green ball? So the probability of having a green ball is equal to the number of green balls in the bag divided by the total number of balls, and that is going to be equals to 10 divided by 15. By our second pick, the number of balls remains the same since the experiment was performed with replacement. So that means at the second pick, the probability of picking a blue ball is actually going to be equals to number of blue balls in this bag of ours divided by the total number of balls, and that is equals to 5 divided by 15. So the probability of picking a green ball and a blue ball is going to be equals to 10 over 15 times 5 over 15. And when we do the math, we have our answer to be 2 divided by 9. And when we convert this to decimal, we have it to be equals to 0.22, approximated to 2 decimal place. A way to show that when events are performed with replacement are independent events is based on the fact that if we decide to switch the side, meaning instead of saying probability of having a green ball and a blue ball, we say what is the probability of having a blue ball and a green ball, we should be able to have the same answer as when we do the same for a green ball and a blue ball. So let us answer the question, what is the probability of having a blue ball and a green ball? Please note, we should have the same answer. So at our first pick, we are picking a blue ball this time. So what is the probability of picking a blue ball? And that is going to be equals to 5 divided by 15. And since this experiment was performed with replacement, so that means the number of balls remains the same at the second pick. So at the second pick, we are picking a green ball. So that means probability of picking a green ball is going to be equals to 10 divided by 15. So that means probability of picking a blue ball and a green ball is going to be equals to 5 divided by 15 times 10 divided by 15. And when we do the math, we can see that we also have our answer to be equals to 2 divided by 9, which when converted to decimal, we have it to be equals to 0.22 approximated to decimal place. So as we can see, the event of picking a green ball and the event of picking a blue ball are actually independent on each other as far as we perform the experiment with replacement. If you learned something new from this video and you really enjoyed this video, I would really appreciate giving this video a thumbs up and subscribe to this YouTube channel. Thanks for making it to the end of this video, and we see in the next one. Bye for now.